continue our discussion on section 4. Okay, you saw this slide yesterday. We talked about reference angles yesterday. So I'm going to remind you how to find reference angles, and then we're going to work with non-unit circle stuff today. Okay? Okay, so let's recall a reference angle is the acute angle that is going to take us back to the x-axis, or the horizontal axis, however you'd like to think of it. So let's draw a picture for each situation. If our angle is in the first quadrant, where's our reference angle?
First quadrant.
It's the same, right? Okay, so in the case of a first quadrant angle, your reference angle is the acute angle in the first quadrant. Okay. If we're in the second quadrant, remember our reference angle takes us back to the x-axis. So let's just talk in radians. How would I find that red angle? Pi minus your angle. Very good. I'm going to do these in radians. That way it makes us think a little bit harder because we're more comfortable with degrees. Okay. Let's talk about quadrant 3. Okay. Remember, our reference angle has to take us to the horizontal axis, whether it's closer or not. Okay. It's always going to be a positive measure. So how would we find this reference angle?
Your angle.
Okay, your angle, because it's going to be bigger, and subtract out pi. And then in the fourth quadrant, if this is your angle, here's our reference angle. How are we going to find that? 2 pi minus your angle. And of course, if you have a degree measurement, you can adjust those accordingly. Okay? It would be my suggestion that you draw the angle in standard form so you can visualize where you are and what calculation you need to make. Okay? So we're going to do 3 examples. First one, start off easy. What quadrants are we in? Okay. So here's our reference angle. Well, okay, that is a good point. If I give you an angle in degrees, I want your answer in degrees. If I give you an angle in radians, I want your answer in radians. Okay? So Courtney, how do we find this one?
360 minus 325.
Which is? That is a number.
35.
Very good. Next example, 7 pi over 5. What quadrant is 7 pi over 5? Quadrant 3. It's over 1 pi, but it's not quite to 1.5 pi. Okay? So there's theta, which means this is our reference angle. So Siobhan, how do we find the reference? going to take 7 pi over 5 and subtract pi, which means we're left with 2 pi over 5. Always positive. Like I said yesterday, if you accidentally take pi minus 7 pi over 5 and get a negative, you should think to yourself, reference angle can't be negative, just make it positive. And it'll be fine. Third example. Well,
There's no degree symbol.
so it's
Radian.
radians. I knew what you were trying to say. Okay, I just wanted you to say the right word. Yes, this is in radians, but there's no pi attached to it, so we're going to have to think about where this is going to be. What quadrant is 2.3 radians?
1, 2, 3, 4.
Okay. So we know that this is 0, and we know that this is pi. Pi is approximately what? 3.14. Right? Which means pi over 2 is approximately 1.7-ish. So 2.3 is going to fall somewhere in the second quadrant.
I think it's pi.
If I'm looking at my back wall.
That's cheating.
How much do you just want us to use 3.14?
Yeah, 3.14 is fine. So what we'll do, okay, this is our reference angle. Okay. We're going to find it by doing what calculation? Pi minus 2.3. So yeah, it's going to be easier if we take 3.14 minus 2.3, which is 1 point, what? I will let you use your calculator. 0.84? Should there be a 6?
184.
0.84? What am I thinking? Oh, I was adding the wrong number. Sorry. I was looking at the wrong numbers. Don't listen to me. Okay. All right. Those are reference angles. Okay. If there is no pi attached to your radian measurement, you're going to have to think about what these decimal approximations are, pi over 2, pi, 3 pi over 2, to figure out which quadrant it's going to be in. And then you'll have to use your calculator to approximate those decimals. Okay. All right. The next thing, let's remind ourselves, okay, you shouldn't need to write this down. This is just a visual for you. This is basically a beefed up version of my ASTC, right? Everybody is positive in the first quadrant. Sine is positive, which means cosine and tangent are negative. In the third quadrant, tangent's positive, so sine and cosine are negative. Fourth quadrant, cosine's positive, sine and tangent are negative. And of course, the reciprocal functions match up there. Okay? The reason I wanted to show you this is because we're going to get into evaluating trig functions in any quadrant. And I might give you some information about the angle, like the sine is positive, but the tangent is negative, and you're going to have to figure out what quadrant we're talking about. Okay? So if you need to draw this at the top of your paper as reference, like on your quiz, that's fine. Okay. So the first kind of example I want to talk about is when we have an angle and we know a point on that angle. Okay. So here we have angle theta, and we know that okay, if we think of this as our initial side and our terminal side, we know that the coordinate -3 and -2 lies on that angle. Okay. Now we don't know anything about the measurement, okay, but we do know that this right here would be the reference angle. Do you agree? That is its reference angle? Okay. And when we were talking about reference angles yesterday, I said the point of a reference angle is so that we could draw a reference triangle. What are the sides of this reference triangle? How long is this side? Okay. And how long is this side? Okay. Some of you may be uncomfortable labeling the side of a triangle as -3 and -2. You can label these as 3 and 2 and then worry about your negatives when you're evaluating your trig functions. Or if you're worried about forgetting the negative signs, you can label the triangles with negative lengths. How many of you want to label our triangles with negative lengths? Is that helpful? Okay. So now what do we need to do with this triangle if we're going to evaluate sine, cosine, tangent, etc.? We need to find the hypotenuse. And how do we find that? Pythagorean theorem. So 2 squared plus 3 squared equals hypotenuse squared. What is our hypotenuse? Square root of 13. Please leave it as the square root of 13. Okay. So now the hard work is over. Okay. We're going to use our reference triangle to evaluate the 6 trig functions of this angle. Okay. So we have an angle that is more than 90 degrees, but we're still using a triangle to get all of those ratios. Okay. So the sine ratio, let me go ahead and, label this. The sine ratio, opposite over hypotenuse. On the quiz or test, am I okay with you leaving your answer like this? Please rationalize it. Okay. Our cosine ratio, what is it? Okay, well, we'll go step by step. Adjacent over hypotenuse, -3 over radical 13. And so when we rationalize, we get -3 radical 13 over 13. If you rationalize in your head, that's just fine. Don't need to see that word. Okay. And then the tangent ratio would be what? Okay. Okay, let's make this easier on ourselves. Okay, yes, I agree that we could take sine over cosine, but we can also look at our triangle and we can do opposite over adjacent. Okay. Now, if you label these all as positive sides, which is fine, you would know that since we're in the third quadrant, sine and cosine need to be negative, and so you need to make sure that those were negative. Okay? Now, when we go to the reciprocal functions, please don't make your life more complicated. Okay? we know that the cosecant is the reciprocal of sine. And when we take a reciprocal, we can take a fraction and flip it. Okay, so if it's a fraction, don't do 1 over a fraction. Just take a fraction and flip it. Okay? Now, if I flip this fraction, we're going to get a radical in the denominator, and then we're going to have to rationalize. Is this the same ratio? Flip this one. That way, your radical goes straight to the numerator, and you don't have to do any extra work. Okay? Or if you'd rather, you can go back and look at your triangle again. You can look at the hypotenuse over the opposite side and come up with that ratio. But do not flip a fraction that you've already rationalized, because then you're going to create more work for yourself. Okay? The cosecant ratio, what is it going to be? Grant?
Negative 13 over 3.
Good. And then our cotangent ratio. Good. Make sense? Nice little reference triangle to help us out. Let's try another one that is similar, but I don't have a picture this time. Okay, let negative 3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. Okay, so go ahead and take 60 seconds, draw the coordinate and a reference triangle. Maybe you want to do it for us up on the board?
Sure.
Okay. You draw yours, Kyler will draw his. Here's Kyler's triangle. I know my last picture we kind of had a circle. That was just kind of for visual effect and relationship because we've been working with that unit circle. You don't need to draw the circle. Just draw the angle and a triangle. Okay? So, here is our angle. The coordinate negative 3, 4 is lying on it, and so Kyler made a reference triangle, sides negative 3, 4, and Michaela with the hypotenuse. 5. Oh, that's nice. That's what we would call a Pythagorean triple, 3, 4, 5. You guys remember that? Anybody give me another Pythagorean triple? There's something with a 12 and a 13.
12, 13, 25. 6, 8, 10.
6, 8, 10.
Mm-hmm. 15, 9, 12.
15, 9, 12. That's 25 and 18.
What was the one you said?
Something.
Okay. Okay, off topic. All right. So the sine ratio. Josie, what is it? 4/5. The cosine ratio. Maggie, what is it?
Negative 3 over 5.
Negative 3/5. Okay? If you did not label this as a negative 3, you would need to remember, oh yeah, cosine's negative in the second quadrant. That's why I think sometimes it's helpful to label it as a negative side, even though it's awkward. Okay. And then tangent of theta, Matt.
4 over negative.
Excellent. Okay. So you'll have some of these problems this evening where you'll have to plot the coordinates, draw the reference triangle, find the hypotenuse, and then find all of your ratios. Okay. Now another type of problem you could come across is something like this. I'm going to give you some information about a trig function. I'm going to give you another piece of information about theta. Find me everything else. Okay. So let's first make a decision. We need to know where to draw our triangle. We know that the tangent ratio is negative 5/4, and we know that the cosine is positive. Think about that for about 10 seconds. The tangent ratio is negative, the cosine greater than 0, that means positive. Hold up how many fingers for the quadrant you think it's in. Seeing a lot of 4s. In quadrant 4, cosine is positive, but tangent is negative. Now cosine, if we focus on this right here, cosine is also positive in the first quadrant, but then tangent would be positive, so that wouldn't work. So we have to go here to the fourth quadrant and draw our triangle. Okay, so here's our reference triangle. We don't know if this is a negative acute angle. This could be a positive angle between 270 and 360. This could be an angle that goes round and round and round and round and finally stops here. It doesn't matter. As long as the terminal side is here, we can find the ratios. Okay? So here's our reference triangle. We know that the tangent ratio is negative 5/4. So I'm first going to label this as opposite over adjacent. Which one would be negative? The 5 would be negative because we're traveling down vertically. Okay, take 30 seconds, 60 seconds. Find me the hypotenuse, please. Sarah, do you have the hypotenuse? Square root of 41. Do you agree? Awesome. So now we need to find the other trig functions. Okay. So sine of theta. Negative 5 over radical 41. So negative 5 radical 41 over 41. Cosine of theta, adjacent over hypotenuse, 4 over radical 41, which we can rationalize. What's nice about this is the tangent, they've already given us. At least know that one. Right? If this were a question on a test and you blanked, at least give me the tangent and cotangent, because you know you can write those down. Okay? But hopefully you won't blank and you can draw the triangle. Okay? And then, do you want to go through the reciprocal ones?
No.
Okay. I'm feeling like you're good. Okay, here's your homework. There's going to be some problems, like the first two examples we did. There's going to be some, like with the coordinates, there's going to be some reference angle problems. There's going to be a few problems that will ask you, what quadrant are you in if sine is positive and tangent's negative? And you have to say what quadrant. Okay. There's going to be some, like the last example, where they'll give you a ratio and another piece of information where you have to put it all together for the quadrant and the triangle. Okay. Tomorrow we will review and have a problem set due Thursday for our quiz. Okay.
Let me stop this real quick.